Welcome back to my channel. Today I'm gonna to solve the equation 5 raised to n plus 5 raised to m is equal to 15,750. The value of n and m from the set of natural number. And we know that in the set of numbers by trichotomy property, whenever we take two numbers, either of the three hold, either n less than m, or n is equal to m, or n is greater than m. So we will have different cases. First, let's consider n is equal to m. Then 5 raised to n plus 5 raised to m is equal to 15,750. Substitute m by n. The equation becomes 5 raised to n plus 5 raised to m is equal to 15,750. 5 raised to n plus 5 raised to n means 2 times 5 raised to n. So we need to divide both sides by 2. We will get 5 raised to n is equal to 7,875. Now, to find n, we see that the left side 5 raised to n, but we need to factorize the right side. When we factorize the prime factorization of the right side, we will get 5 cubed times 2 times 3 square times 7. From prime factorization uniqueness, we get the contradiction. Therefore, we conclude that the value of n and m never being equal. Now, we need to come to the remaining case, n less than m or m less than n. Let's take the first one. Let n be less than m. So from the factorization concept, whenever we have an expression of the form 5 raised to n plus 5 raised to m. So 5 raised to n, n less than m means 5 raised to n is a factor of 5 raised to m. So we can take as a common factor 5 raised to n. So it remains 1 plus 5 raised to m over 5 raised to n. Then, from the property of exponent, 5 raised to m over 5 raised to n means 5 raised to m minus n. So 5 raised to n times 1 plus 5 raised to m minus n is equal to 15,750. Okay. Now, first we need to confirm that the expression 1 plus 5 raised to m minus n is not divisible by 5. The other thing, we take the prime factorization of the number 15,750 as we seen before. So the right side we have prime factorization, the prime factors 5, 2, 3 and 7. What about the left side? We have 5 as a factor, and we have to confirm that the multiplicity of the factor 5 in the left is n. Let me recall the prime factorization concept. Whenever we factorize a number by prime factor, we know that its factorization is unique. You will have k factors, p1, p2, pk, with its multiplicity n1, n2, nk. That's unique. So the number 1 plus 5 raised to m minus n, it can be written as 1 plus 5k. 5 raised to m minus n is divisible by 5, so we can write as 5k. That means 1 is the remainder whenever we divide the number 1 plus 5 raised to m minus n by 5, we will have a remainder 1. That means this number is not divisible by 5. So we are sure now the number on the left side has a prime factor 5 with multiplicity n, and on the right side we have a prime factor 5 with multiplicity 3. So 5 raised to n is equal to 5 raised to 3, and the remaining part of the numbers 1 plus 5 raised to m minus n is equal to 2 times 3 squared times 7. That's 126. From the first equality, we get that n is equal to 3. 1 plus 5 raised to m minus n is equal to 126. Subtract both sides 1, it will give us 5 raised to m minus n is equal to 125. N is 3, so 5 raised to m minus 3 is equal to 5 cubed. So from this equality, the multiplicity of 5 in both sides should be equal. M minus 3 is equal to 3. Therefore, m is equal to 6. Now, the other case does not have any impact on our problem. It will give us the same value. Thanks for taking the time to watch.